Okay, in this video I am going to show you how to write fractions as decimals. Okay, and I'm going to do that by helping you with your class notes that you can download from my website. And these class notes are called Fractions as Decimals. Okay, converting fractions to decimals. So the first thing we have to look at is vocabulary. The definition for a terminating decimal is a decimal that the digits end. For example, 0.4, that's all it is to it. It doesn't keep going. 14.565, it stops right there. 8.25, it stops right there. Now, one thing that I'm going to mention that is going to help us a lot while we do this is to use proper place value. And we need to know that this 4 right here, right now, the place value that 4 is in, that's the tenths place. Okay? So we need to know our place value. That's our tenths place. And then this 6 right here would be our hundredths place. And the 5 would be our thousandths place. Okay, so I'm going to put this 5 right here as the hundredths place so that we know. Notice that it has a TH at the end. Okay, this TH right here, THS, because it's to the right of the decimal. If it was to the left of the decimal, any place value to the left does not contain the THS. It just would be 100, okay, but not hundredths. And then the one after the hundredths place, this one here, this one would be the thousandths place, again with the THS. Notice that the first place behind the decimal is the tenths, the second number behind the decimal is the hundredths, and the third number behind the decimal is the thousandths. Alright? Okay, now let's talk about repeating decimal. A repeating decimal is a decimal that has a pattern, okay, in the digits, and it repeats forever. For example, the pattern in this decimal here is just 33333. That's the pattern, and it keeps on going. So that's why there's those 3 little dots right there. In this decimal, 4.1717, that means that the 1 and the 7 are always repeating. That's the pattern that repeats. Okay, and in this one we can see that the 3 does not repeat, but the 8 and the 5 do repeat over and over. So that's the difference between a terminating decimal and a repeating decimal. One, the terminating decimal stops. The repeating decimal has a pattern that does not stop. It goes on forever. Now, instead of writing these 3 little dots in math, we don't write those 3 little dots to mean to be continued. In other words, we write the bar notation. Okay, and that's the next vocabulary word we need to look at. The bar notation is used to indicate that a number repeats forever. For example, 0.333 ... wouldn't be written that way. It would be written with a 0.3 and the bar on the top. Okay, so it would be like 3/10 repeating. And this would be 4.1717 repeating, so it would be 4.17 repeating with the bar on top of the 1 and the 7. Let me make sure that's really clear. Okay, the bar, that line is on top of the 1 and the 7 because both numbers are repeating. Now, let's talk about how we change. Here's what this lesson is about. Let's change those fractions to decimals. Okay, here's how we're going to do it, and we can do that in one easy word: divide. That's it. If you divide, you get your answer as a decimal. So, but how do you place your numbers? Well, we have to look at 3 other vocabulary words that you should know by now, because you're in 7th grade and you need to have already known, at least talked about dividend and divisor and quotient. So the dividend is the number that is being divided. The divisor is the number that is doing the division, and the quotient is the answer to the division. Okay, in other words, the dividend is going to be the number on top. That number on top as a fraction, that's called our numerator. Okay, so make sure you write that down. The dividend, the number on top, is the numerator. That's the number that goes inside the division bracket. Whenever you sit down and you change the division to what you're normally used to dividing, it goes inside. That number is the numerator. Okay, I'm going to scoot over so you can see it. Now, the other number, the one that's doing the division, is the divisor. And that number we can get from the denominator, the number that's below the fraction bar. So there it is. Okay, and then the quotient, of course, I'm going to box it in because that's going to be the answer to the division. All right. So the denominator is that 2, and that 2 is the divisor, so it goes outside our division bracket. So I'm going to put a arrow so you remember, and I'm going to abbreviate it, denominator. I'll go ahead and write it out so you can get practice with your vocabulary words. Okay, so that's the denominator, and of course on top we have the answer to the division, which is called the quotient. Okay, now remember, the top number goes in and the bottom number goes out. That's the easy way of saying it. Okay, proper vocabulary would be the numerator goes inside, the denominator goes outside. But if you want an easy, quick way to remember it, just remember top number goes in, bottom number goes out. And this is what I like to tell my students. Top number, T for top, goes in. That's the I for in, top in. Bottom number goes out. So if you remember Tybo or Tibo, however you want to pronounce it, that will tell you every time how you place the numbers of your fraction into a division bracket. Okay, I'm going to do one example. For example, 3/4. The top number is the 3. So it goes inside because it's top in, bottom out. The bottom number goes outside. So there's my 4. Okay, so from the fraction, you can write yourself a division. Now that's not an equal sign that I just drew. That's an arrow to show you that it goes from the fraction form to the division form. Okay? Now the second part here of your note says the division ends when the remainder is 0 or when a repeating pattern begins. So that means that you have to be able to divide a fraction, divide the numbers until you have a remainder of 0, there is no remainder, or until you notice that there's going to be a repeating decimal as your answer. Now, here we go. We're going to leave that alone for right now because we'll talk about division in just a few minutes on the examples. On the other side of this page, there are 6 fractions that we have to convert to a decimal. So, 4/5, we're going to do top in, bottom out. Top goes in, bottom goes out. Okay, let's do that for all of them. Top in, the top number is 3, the bottom number is 25, so it goes outside. Now 7/8, we're going to do that also. Top goes in, bottom number goes out. Alright, now let's work it out. The first one, 5 divided by, or 4 is being divided by 5. So what I noticed right off the bat is that 5 is too big to go into 4. 5 cannot go into 4 because 4 is smaller. So I'm going to put a 0 on top of the 4, and I'm going to add a decimal and a 0 inside that division bracket. Now that I've done that, that decimal can move straight up into my quotient, and now I'm able to divide because now that that decimal is not really there, I have a 4 and a 0, that's 40, and I know that 5 goes into 40 8 times. because 5 times 8 is 40. So I'll go ahead and put it down and I subtract, and when I subtract I get a remainder of 0, so I'm finished, and my quotient, my answer is 0.8. Okay, now let's do this other one. It's a little bit more complicated. Some of you may be afraid of those numbers that have 2 digits on there when we divide, but don't be afraid of them. Just take one number at a time. For example, 25 is too big to go into 3. So I'm going to add a 0 on top because it cannot go into 3. So now I can add a decimal and a 0, and I can bring up that decimal straight up. Make sure you keep those numbers aligned and that decimal goes straight up. Okay, now you have a 30. Can 25 go into 30? Yes, one time. So I'm going to put a 1 on top of that 0 for 30, and then I'm going to put 25. And I can regroup, and if I regroup, then this 3 becomes a 2, and that 0 now becomes a 10. So 10 minus 5. 10 minus 5 is 5. 2 minus 2 is nothing, 0. So I still have a remainder here, 5, so I have to add another 0 and bring it down so that I can extend my bar on the top so that I can keep dividing. Now can 25 go into 50? Yes. How many times? 2 times. Because 2 times 25 is 50. So when I subtract them, I get a remainder of 0, and I'm done. 3 25ths is 0.12 or 12 hundredths. Okay? The last one that I'm going to do with you is this one right here, 7/8. So 7/8, again, 8 cannot go into 7, so I will put a 0 on top of the 7, add my decimal behind the 7, and add a 0 behind the decimal. Bring up that decimal into my quotient, and 8 goes into 70. Let's see, I know that 8 times 8 is 64, and 8 times 9 is 72. So it's too much. So I don't want to do 8 times 9, but I do want to do 8 times 8. Okay, that's just below 70, 64. Now if I regroup again to finish my division, that 7 will become a 6 because I'm borrowing 1 from it, and then that 0 will become a 10. So 10 minus 4 is going to be 6, and 6 minus 6 is nothing. You can put the 0 or you can just leave it blank. I like to leave it blank. Okay, I'm going to add a 0 and bring it down. And that's 60. Now I can say 8 goes into 60. Well, I know it's not going to be 8 times because I already know that's 64. So it's going to be 1 less than that. It's going to be 7 times. Okay, so 7 times 8 is 56. And if I regroup this correctly, that 6 becomes a 5. That 0 becomes a 10. 10 minus 6 is 4. And 5 minus 5 is nothing. I still haven't found a repeating pattern or a terminating decimal. I have not gotten a 0 for a remainder. So that means I'm going to have to add another 0 and bring it down. And that means that I have 40. Now I know 8 goes into 40 evenly because I know that 8 times 5, which is going to be my next number in my quotient, 8 times 5 is 40. So when I get that 5, I know that I'm finished when I subtract the 2 40s and I get a terminating decimal, 0.875 or 875 thousandths, because that's in the thousands place. Remember, tens, hundredths, thousandths. So this would be read as 875 thousandths. We always say the last place value after we're saying the decimal. Alright, so I'm going to let you do these 3 problems by your own, the 1/3, the 5 9ths, and the 3 11ths. Remember, if you find a repeating pattern, you can stop, or in the just use the bar notation, or if you get a remainder of 0, you can stop as well. Okay, and then you can do that application problem where Benny's teacher gave him a score of 34 over 40 on his quiz, and they want to know what decimal is equivalent. What decimal is equivalent to the score Benny received. All right.